Okay, so let's cover section 6.3, Introduction to Linear Inequalities. And your learning outcome is to explain and illustrate strategies to solve single variable linear inequalities. So an inequality is just like an equation, except it's got this inequality sign. It's got this greater than or less than sign going on, okay? So in your notes here, they're going over the signs for you. This sign less than means it's below or it's under. As soon as you add this line to it, it becomes less than or equal to. So some words that might help you know it's this sign, if they say up to, at most, no more than, maximum. Greater than looks like this, and words that can tip you off that they mean this symbol are over or more than, and then the opposite of less than or equal to is greater than or equal to, and some words that might help you are at least or minimum. And then do you remember way back in elementary school when your teacher tried to teach you about inequalities and she brought out the Pac-Man? That's the way it worked for me. So this funny little picture here is to remind you that Pac-Man's going to eat the bigger number. So 5 is greater than -2. So of course Pac-Man wants to eat 5 because it's bigger. Okay, Pac-Man's hungry and he wants the bigger number. Over here this says -10 is less than -9. And I know it seems like 10 should be bigger than 9, but remember that -10 is farther away from 0 than -9 is. So -9 is actually bigger, okay? And then, just to help you out, I found a video on YouTube. It's called Equal, Greater, or Less Than. It's in the links section of my website. So if you feel like you want to watch a little bit more about equal, greater than, or less than, access this video that's in my links. Okay. So example number 1 in your notes says that we're going to write an inequality to describe a situation. And it says here that we are to define a variable and write an inequality to describe the situation. So A says the speed limit is 60. So in A, it means that the most you could go. The most that you could, most isn't a very good word. In terms of speed is 60. Okay, so you could go 59, you could go 58, you could go 0, and you could go 60. Okay, so because we're talking about speed, let's use S, and I'm not going to use this kind of S because often it looks like a 5. I'm going to use a script. Okay, and S can be at most 60. It can't be bigger than 60, okay? It can't be 61. The most you can go is 60. 60 is the utmost highest it can be. And remember that Pac-Man always wants to eat the biggest number. So 60 is going to be the biggest it can ever be, but it can also equal 60. So inequality that could describe or could be used for the speed limit of 60 is S is less than or equal to 60. All right, B says you must be at least 16 years old to get a driver's license. Okay, so let's go D stands, no, A. Let's go A for age. Okay, so A and 16. Now, how do they relate to each other? Your age can be 16 and older. It can't be younger than 16. So 16 is the youngest you can be. Your age can be 16 or more. So Pac-Man's going to want to go this way. This is always going to be the bigger or equal to, okay? Because you can be 17, you can be 18, etc. And so those numbers are bigger than 16. So an inequality is A is greater than or equal to 16. Okay, so let's try the check. Pause here, try the check, and then come back. All right, so number 1 says, let T represent the temperature in degrees Celsius. Write an inequality to describe each situation. And A says, for temperatures less than 0 degrees Celsius, make sure to wear warm clothing. Okay, less than. It doesn't say equal to, it says less than, okay? So because it's less than 0, 0 is as big as it's going to get. So we have to put our symbol this way. T is going to be less than 0. All right, B says that the highest temperature we've had this week was 12 degrees. 12 is the highest, okay? So Pac-Man wants to eat the 12. That's as big as it's going to get. So the temperature has always been less than or equal to 12. Okay, next. Remember about linear inequalities? It says a linear inequality may be true for many values of the variable. So remember when we were talking about driver's license, it said you had to be at least 16. But 16 wasn't the only possibility. You could be 17, you could be 18, you could be 19. So that's the thing about inequalities is there's many things that can make it true. Not like equations where only one thing makes it true. Inequalities has a bunch of things it can possibly be. And lots of times we show that on a number line. So example number 2 says determining whether a number is a solution of an inequality. And it says, is each number a solution of the inequality x is less than or equal to 3, and justify the answers. Okay, so on my number line, here's 3. Okay, here's my target. I don't want it to cover 3. Let's see if I can move it up a smidge. This is where 3 is. Okay, there we go, right there. Okay, so x has to be less than or equal to 3. So you know what I'm going to do? I'm going to highlight where x is less than. Here is where x is less than or equal to 3. Over here is where x is greater than 3, but x has to be less than 3. So I'm going to put that highlight just to help myself. Now 5. 5's over here. So is 5 a solution to x is less than or equal to 3? Is 5 less than or equal to 3? Well, no, it's not. 5 is greater than 3, so it's not less than or equal to 3. Okay, 3. 3's right here. Is 3 less than or equal to 3? Well, 3 isn't less than 3, but it certainly is equal to 3. So yes, 3 is a solution to this inequality. Okay, 0's right here. Is 0 less than or equal to 3? Sure is. You betcha. And negative 2. Is negative 2 less than or equal to 3? Negative 2's down here, and absolutely. Negative 2 is less than or equal to 3. So sometimes a number line helps you to visualize. So here's the check. Have a go with this, and then come back and let's see if you got it right. Okay, 1a says is 8 a solution of the inequality x is greater than 0? Okay, here's 0. Okay, here's 0. And it wants to know is x, it says x is greater than. So this is the part of the number line where it's bigger than 0. Okay, so here it says 8 is 2. Here's 8 right here. Oops, let's get a pen going. That's funny. There we go. Here's 8. And 8 is to the right of 0. So, of course, 8 is the solution. Okay? Because 8 is greater than 0. Of course, 8's the solution to that. All right, what are 3 other numbers that are solutions to x is greater than 0? Anything on the right side of 0. So, simply 1, 2, and 3. You could shake it up and go a million if you wanted to. Anything to the right of 0 is a solution. Okay, so now it says the solutions of an inequality can be graphed on a number line, kind of like what I was doing. And the first example that we're going to go over here is a is greater than 0, okay? So it says here that a is greater than 0, so 0 is not included in this solution, okay? Let's go over that sentence. 0 is not included in the solution of a greater than 0. So let's think about that. Is 0 greater than 0? Well, no. 0 isn't greater than. 0 is equal to 0, but it's not greater than. So 0 is not part of the solution. So we put an open circle, and that needs to go into your learning journal, please. That we need to put an open circle on 0 if the answer is not included in it, okay? And then we've got the second example here. It says z is less than or equal to 0, but because we've got that or equal to, we put a shaded circle, or sometimes we call it a closed circle. Okay, so because the inequality is z is less than or equal to 0, we put a closed circle on 0, and then it's anything on this side. Okay, so open circles for greater than or less than, closed or shaded circles for less than or equal to, or greater or equal to. Okay, so we have open circles for this or this, but we have a closed circle for that or that. My pen is acting so weird. There's the comma there. Okay, so let's give that a try. It says graph each inequality on a number line and then write 3 numbers that are possible solutions of the inequality. Okay, so A is B is greater than 5. So notice I didn't write any numbers on the number line because I don't need a full number line full of numbers. The only really number that's important is 5. So I'm going to put 5 right in the middle. If you want to, put 6 and put 4, but you don't have to. Okay, 5 is the number that's important. Okay, B is greater than 5. Because it's a greater than, it needs to be an open circle because it can't include 5. Okay, so open circle on 5. And now you got to think, okay, B is greater than 5. Where on my number line is greater? And hopefully you're thinking over here. This side is where I'm greater than 5. So I want you to take a highlighter, or, sorry, that's supposed to be an arrow. I want you to shade it with a pencil or a pen or use a highlighter and show me that anything to the right of 5 would work, okay? Because 6 is greater than 5, 7 is greater than 5, 10 is greater than 5. So what you're showing me on the number line is anything to the right of 5, but because it's an open circle, it's not including 5, will work or satisfy this inequality. Okay, second one. We have y is less than or equal to -1. Again, the only thing that's important on my number line is -1, but if you want to, put 0 and put -2, if you want to. Okay, y is less than or equal to -1. Because it's a less than or equal to, you have a closed circle because it could equal -1. Okay, y is less than. Less than means we're on the left of our circle. So get out your highlighter, and it's everything on this side. And let's see if it will let me. There we go. That's what I wanted to draw this time. Okay, y is less than -1. Anything on the left side. All right, third one. We have -4 is greater or equal to n. We need -4 on our number line. If you want, you don't have to. Okay. What kind of circle are we going to have? Closed or open? We are going to have closed, or -4. Okay. -4 is greater or equal to n. -4 is the biggest it's going to be. Okay? It's not going to be any bigger than -4. So we want, again, this side. Okay? Because 4 is greater. -4 is greater than n. So it means n's on this side because -4 is the biggest it's going to be. Last one, -1 is less than r. There's -1. Open circle. Okay, again, if it makes you happy, put a 0, put a -2. Now, -1 is less than r. Okay, so for -1 to be less than the numbers have to be bigger than -1. So we're going to shade in our number line on this side. So what you got to remember is, first of all, put your number on the number line. Think open circle, closed circle, and then think, okay, which side do I shade? And talk yourself through it. Okay? Think about, is it on the right side or left side? Am I bigger or am I less than? All right, try your check. Okay, so the check says graph each inequality on a number line and then write 3 numbers that are possible solutions for each inequality. So A says h is less than or equal to 4. Here's 4. What kind of circle? We need a closed circle. Because it can include, oops, I'm still on my highlighter. Let's get rid of that and try a pen. Here's 4. Closed circle. Okay. H is less than or equal to 4. And you know what? The number line's kind of telling you, we can't be over here, can we? We haven't given you any room. So the number line's kind of giving it away for you. h is less than or equal to 4, so of course we're talking about on the left. Okay, less than is this way. So anything that way is valid for an answer. And then if it wants 3 numbers that are possible solutions, well, we could say -1 is possible, we could say 0 is possible, and we could say like 2 is possible, because -1 is less than or equal to 4. 0 is less than or equal to 4. 2 is less than or equal to 4. Now remember how 4 had a closed circle? So 4 is actually a solution, because 4 is less than or equal to 4. Because it's got that closed circle, you can include it. Okay, B says -3 is less than x, so I'm going to kind of go in the middle, and I'm going to put -3. -2 would be here, -4 would be there. Okay, -3 is less than x, open circle, can't include it. So put a nice, obvious open circle around -3. Okay, -3 is less than x. So in order to be less than, we must be talking about the right side. So highlighter this way is the solution. Try really hard not to get the highlighter in the circle. I should have tried a little harder. I can't include -3, so try not to put your line including the circle. And then, okay, what's bigger than -3? Well, 0 is, -2 is, and anything, 10, doesn't matter. Anything on your number line, because -3 is less than 0. -3 is less than, what did we say here? -2. Okay, again, it's one of those weird ones, but remember -2 is closer to 0 than -3 is. And of course, -3 is less than 10. Okay, the obvious number. So a lot of talking to yourself in these kind of things, and to try to figure out which is greater than or less than. So that's the end of 6.3. In your book, I believe there was not, there was no skill builder for 6.3, but you do have your online quiz, and go through your practice, please.